Hello, everyone. All right. Hi, everyone. My name is Sheikha Sabti, one of the GDG Kuwait organizers. To welcome you all and thank you for registering in this session. This session is provided by GDG Kuwait as part of DevFest Kuwait event. So GDG Kuwait is a group of Google developers with different backgrounds but have same interest in technology development. The main goal of our GDG Kuwait group is to share tech knowledge and skills with those who seek such knowledge for free. And by that, we are contributing in developing a good tech platform in Kuwait and around the world through our participation in DevFest Kuwait events. GDG Kuwait has done many workshops and talks such as Django workshop for web development and Android and iOS workshops, cybersecurity, Google Cloud, tech hackathons, and many contributions to share good knowledge. This time, we are providing Google Study Jam, Kubernetes on Google Cloud as a quick jump start to get a hands-on practice configuring Docker images, containers, and deploying fully-fledged Kubernetes Engine applications. This quest will teach you the practical skills needed for integrating container orchestration into your own workflow. I mean, who knows, you might be the next exclusive Google Cloud Digital Badge holder. So our presenter for this session is Shruq Saleh, a full stack developer, agile and design thinking enthusiast, interested in DevOps and CI and CD, continuous integration and continuous delivery. She likes making games, holding art workshops, and participating in hackathons. Currently an active member of GDG Kuwait as an organizer and Women Tech Maker Ambassador. And good luck, Shruq, and wish you all a happy learning session.
Thank you, Sheikha. Also, I'd like to introduce Dr. Zainab Al-Miraj and Arwa Al-Jasir. They will be also assisting us and presenting for the session. And if you have any questions, you can also ask for their help in the chat section. So let's start. Before I start the lab, I thought maybe we could do on containerization. So what is containerization? As we start, most people tend to default to something like Docker or even Kubernetes these days. But container technology has actually been around for quite some time, and it was I think around 2008 that Linux kernel introduced something called C groups or control groups, and that's what paved the way for different container technologies we see today. That includes Docker, Cloud Foundry, Rocket, and other container runtimes out there. So let's start with this. I'll first explain the difference between virtual machines and containers. So a lot of people, when they think about containers, they also think about virtual machines. And they come and they say like, okay, so what's the difference? Why can't I just use virtual machines instead of using containers? So us, like as a developer, let's say I wanted to create an application. It's a service. Let's say it's a Python service, an Node.js service, anything, React.js service, right? And I want to, what do you call it? Push it into production. And to do that, so let's say if we're using the virtual machines, the first thing is that we have here the hardware, which holds the virtual machine, and then we have the host OS, and then the hypervisor. So, what do you call it? Actually allows us to create those virtual machines. All right, so it's really important for virtual machines. And then let's take a look at this part, which is the place where all applications share the resources from. Creating the the part for the host OS and hypervisor takes up this amount of resources. And then if we push our application, which we create a virtual machine first, and then we set up an OS, and then the libraries, and then the application itself, it starts to take this amount of resources. Now, if I try to do more, it will take almost a lot of resources, and that's because each virtual machine has its own operating system that's being hosted inside of it. So this brings us to a big problem, which is that there's a lot of resources that are being wasted because of the amount of loaded OSs that we have to use for each virtual machine. And to solve this problem, containers became to be. So the way we create containers, or first generate them, we have to use something called a manifest. So a manifest is like a file that describes the information that is the layers of that container. So for example, what type of application we're using. It's a Python image, it's a Node.js, something like that. And then it gives you like the whole description for that. And it can be a Docker file, or I think, I can't remember what other types, but other container systems use different types of files. So let's focus on the Docker side. And then what happens next is that from the Docker file, we build an image, and using that image, we create the container. So the container is the place where you have all of your resources where you host that application inside of it in its own environment. Another thing that we benefit from containers is that let's say you built this application on your machine, you're using a Windows or Mac OS or a Linux, and you want to have this application work on other OSs. Because of the different environment variables that may come in, it could cause like problems and dependency problems. So let's say, oh, this library doesn't work on this type of OS, this machine doesn't work on this. So containers help us containerize these applications. So none of the outside variables could cause a problem for our application, so they can live alone. So in containers, it's a bit different. We have obviously the hardware, the host OS, and then we have something called a runtime engine. Over that runtime engine, we start creating the application containers that services that are going to work inside the container. And if you notice that each of these, first of all, they don't have their own OS. Because they share the resources from the same space, only the library and only the application. So that saves a lot of resources when we're using that. And at the same time, it allows these applications to communicate together in the same space. I hope I was able to give you a quick idea on what are containers and what you can actually do with them. All right. So let's get set for the quick labs, and I'll leave you with Dr. Zainab to show you the steps to do that. Dr. Zainab?
Hello, everyone. How are you? Hope you're excited to get started, as we are. So what we're doing today is setting up for your quick labs. And if I share my screen right here, you will be able to see. The steps that we're going to follow. So what we're going to do is open a link, and I'll share this in your chat. If Shuruk could do that, please. Here we go, I can do that. And what we'll do is we're going to go to this quick lab quest number 29. That's going to be our session for today, Kubernetes in the cloud. You're recommended to open this in incognito window. You usually have trouble if you don't do that. If you've ever enrolled in a quest before, or in this quest specifically, then we ask you to unenroll and then follow the steps that we're going to do just now and enter the code. So this is what you should get if you're signing in. You're going to be asked for Quick Labs terms of service. So we're going to just go into saying I'm not a robot and finishing the verification. Oops. Okay. Okay. What I'm going to do is go to Kubernetes. Oh, click the link again, I guess. Let's try that again. Okay, so here I get to enter my code. So I'm going to copy the code. And I hope you're following along. If you have any issues.
Dr. Zina, can you give sharing access for the document? Viewer, not editor. You gave editing permission.
I gave. It was shared. It should have been a view anyway to begin with.
For some reason, they were saying they don't have access. Okay.
So it should be fine.
Yeah,
so
but guys, don't edit the file.
All right, so don't edit the file. Yeah. Okay, so here I am. I was asked to enter my access code, and I've copied and pasted it. Again, I'm going to do the verification. Are there any more? No. Okay, then I should be good to go. If you've got to the stage, then you're perfect. Then we're going to do the enrolling quest. And hopefully that takes you to the first step, which is introduction to Docker. I'm going to wait right here for about 3-4 minutes. If you have a problem getting to this stage, then Arwa, Shuruq, and myself will be helping you. Okay. We don't want to start lab until we're all ready, because there's a timer. And if you start it and we are not ready, then you're going to fall behind and you'll have to repeat the lab again. It doesn't take an hour, so you shouldn't worry.
All right, I'll share my screen. If you guys have any issues, just mention them in the chat. Okay. Okay. All right. Let's see where we go. So basically this challenge, it has multiple labs, as you can see here. And each lab has an on-hand experience for you. If you've never done Quick Labs or Google Cloud training, this is the cool thing about them. So they give you, the access gives you credits that allows you to use all of these labs for a whole month, at least for the quiz that we're going to sign up for, I guess. Make sure you enroll to it with the code. Now, so we are going to start with the first one, which is Introduction to Docker. Right. Okay, so as I said, Docker is an open platform for developing, shipping, and running applications. With Docker, you can separate your applications from your infrastructure and treat your infrastructure like a managed application. It helps you ship code faster, test faster, deploy faster, and shorten the cycle between writing a code and running it. So what it does, it combines it with the kernel containerization feature and tooling that helps you manage, deploy your application. So what we're gonna learn: build, run, and debug Docker containers, pull Docker containers from the registry and push to the registry. All right. So let's start with the first thing. So this is very important. You have to listen carefully to what I'm gonna do. Do not run fast with the work. Let's take it easy. We have enough time to finish the lab. All right. So the first thing that you gotta do is press start lab. All right, it'll ask you to identify traffic lights and then verify. Use lunch with credit. All right, this one. Make sure you press this. Okay, I'm gonna check. All good. Okay, and we just wait for it to pre-provision the lab resources because we need this thing here. Do you see this? It will pop up here. Let's be patient. Patience. Takes a bit of time. Also, I think we're not gonna go through all of the labs today. We'll try to finish 3, and maybe you can continue the rest on your own so you can get the badge, or if you guys like what we're doing, we can set up another session and do it together. Okay. Any questions so far? Trouble? Anything? Make sure to use the general chat for that. Okay. All right, we got our code. Now, the important thing that you need to do here is to open this in an incognito window, right? Oops. Yeah. So let me share my screen for that window. Do you see the new window? Please let me know. Oh, I don't think so. So let me switch. All right. So the trick here is that I'm gonna have to do this. Let me do this. I'm gonna share the whole desktop entire screen. Yeah, share. All right. Just to make sure, I'm gonna be here as well, right? Because we're gonna need this page. Okay, so make sure use another account, right? Copy this, all right? Paste it here. Press next. Copy the password they give you. Paste this here. Go next. Accept. Make sure to be in an incognito window. This is very important. Do not use your personal account for this, right? Use the account information that they give you. Confirm, do not update anything, just press confirm. All right. Agree to this terms and services. Do not select the email updates thing. Agree and continue. Obviously, mine is selected as Egypt because I'm currently in Egypt. Yours is going to show you the location you are at. And then let's just hide this part. Okay. And then you see here, activate Cloud Shell. Can you see it? It's at the top here. You click on it. This will open the Cloud Shell for you. Let's hide this thing. Let's increase this and say continue. Right, we wait for it to provision. Just gonna check if we have any messages or anything. Yeah. All right, let's continue. Okay, so now we have, this is like a Cloud Shell, a terminal that we're going to use to interact with the Google Cloud platform. Okay, now the next step, we're back here. The next step is we did all of this. This is done. And then we come here, activate Cloud Shell. This is what we did. And then we can skip this part. All right, these are just for your general purposes. Okay, now the first step is that we're gonna do is say Docker run hello world. So what this is gonna do is gonna pull an image, all right? What it said here, unable to find image, all right, locally. So it's pulling it from the library called hello world, and it pulled it, and then it gave you hello from Docker. This message shows that your installation appears to be working correctly. Now, so this simple container returns hello from Docker. While the command is simple, notice that the output of the number of steps it performs. So you can see here what where is it? Yeah, these steps here. All right. The Docker daemon searched for hello world and it couldn't find it. And so what it did, it pulled it from the registry. Now, if we do Docker images, this will give us a list of images. Let me increase the size of this because I'm not sure if you can see this clearly. Yeah. Okay. So what you can see here, it says the repository tag image ID created in size, right? So hello world is the repository that we pulled, and it has a tag called latest. This is the image ID, and it tells you what's created and what is the size of the image. All right. So the image pulled has a SHA-256 hash format. This specifies the Docker image that has been provisioned. Since the Docker daemon couldn't find it locally, by default it searched for it in a public registry and it pulled it. So let's run it again and see what happens. All right, Docker run hello world. So what it did here, it didn't pull or do any steps, and immediately it gave us hello world, hello from Docker. All right. So the second time it did immediately pull it because now you have the image in your local registry. All right, so finally, let's look at the running containers. And to do that, it's Docker PS. All right. You can see that there are no running images because what happens is that when you just say Docker run hello world, it just runs it one time. It doesn't keep it running in the background. So for us to do that, before we do that, you need to see that it actually is there, but it's not active. So you can see here, these are, all right, and you can see here that when was it created, it exited, that means it's not running, and the names of the containers. So these names are randomly created, by the way. So you can actually assign a name. I'll show you that later if you want to do. Yeah, here it is. Docker run, and then you use the upfront dash a name, and then the name of the container that you want to give, and then the name of the registry, hello world. All right. Now the next step is for us to build. Let's build a Docker image, and we're gonna do that on a simple Node application. I hope I'm not going too fast. Any questions? No? Okay. Make dir test. So make dir means make directory, I call it test, cd, go into it. All right, so we're gonna do that. Let's copy that. And here we go. Okay. So now we're inside the test directory. Now we need to create a Docker file. You can just press copy here. So if you remember, a Docker file is like a manifest that explains what the image should look like and what are the layers inside of it that needs to do. So if you see here that each line here, so from node, this is the first layer in the Docker image, right? And then you have work dir, app, add that app, contents to the container, expose it to port 80, and then run the command node app.js, and then end of. Okay. All right. Now, the next step is that, as I said, the initial line specifies the base parent image, which is the official Docker image for Node version 6. This one. And then the second one is we set the current working directory to /app. And then in the third one, we add the current directory contents to the container, and then we expose the container to the port that we want to accept the connection through. All right. Now we'll write a Node application, and to do that, let's just copy this line. Well, you don't have to go into an editor or do anything, right? You copy paste it, press enter, it created a Node application. All right, that exposes port 80, and what it does, it has an API call that prints hello world. All right. So it's a simple HTTP server. And note again that the dot here means current directory, so we need to make sure that we use that in the command when we're running it. So we say docker build -t, and -t means it's like telling it it's a name tag format. So this is the name and this is the tag. So this is the name of the registry, and 0.1 is the tag that we're using for this one, version 0.1. All right. We'll do this here, and let's see what happens. Make sure to authorize this, and it will take a few minutes, I guess. You can see what it's doing here. It's building each layer. So the first step is pulling the image, the node image from the registry. All right, it's taking a few minutes. Right, let's see. And then the second step, which is the second layer, setting up the working directory. Third step, adding it to the container. The fourth step is exposing the port. And then the last step is running the command node app.js. All right. And it said that it's built and it's tagged as node app 0.1. Okay. Now the next step is, let's see what Docker images do we have. So we have the hello world, we have the node app that we created, and we have the node that we pulled from the official registry. All right. So these are the current images that you have. So there are two things that you need to know. First thing is that the size of the image is relatively small for the node app. Other versions of the node image, such as Slim or Alpine, can give you an even smaller image for size portability. It depends on the tag that you're using when you're specifying the node image that you want to use. Usually, if you don't define the tag, it will just assign latest to it. Okay, so in this module, we're gonna run our code inside the container. So let's copy this. So what this does, we have docker run -p. So -p exposes the port that we're gonna use. We're gonna use port 80, and 4000 is the port that port 80 will be connected for the container. So the container itself is gonna be connected to the app through this port. Okay, and then you have --name, which is the name of the container, and then which image it is using. Cool, let's do that. Let's stay here, and we get server running at HTTP 0.0.0:80. Now we want to know if it's working, so let's make a call for it using curl. All right, but before that, you need to open a new terminal, so you can do that because we have it running here. We don't want to kill that process. So press the plus button here, it opens a new terminal, and then we paste the curl, and we get here, hello world. Cool. So this is the response that we got from our live app container. All right, so the container will run as long as the initial terminal is running. So if we close the first terminal, it will stop running and that endpoint anymore. All right, you need to specify all right, if you want the container to run in the background, we just add the dash the operator, flag. So it would continuously run in the background. All right, let's see. Now the next step is let's close the initial terminal and then run the following command to stop and remove all containers. So here I'm gonna close this. All right, let me show you something. If I make a call again, oops, oh, interesting. All right, I guess it's because it's on the cloud, that's why it's doing that. Let's remove and kill this Docker image. So we say Docker stop my app, Docker rm my app. Rm is removed. This will take a few minutes. All right, a few seconds actually. Okay, so this is done, right? So now we don't have that image anymore. Now let's run the following command to start the container in the background. Sorry, we don't have that container live anymore. It's not that we don't have the image. So let's run this. All right. So we run it. All right. And let's list containers. So you can see here that it's up and running for 6 seconds, and that this is the port that it is exposing. So from port 4000, we're accessing port 80 on that. All right. Now, let's see. If you want to, for example, see all of the logs or the events that are happening on the server, you can use Docker logs and then add the container ID. So the container ID is this value. It's a really long value. If we don't have many containers, we can just use like the first 3 values or the first 6 values. So like if I say 1v6, it will know that I am trying to get to this one. All right. Now let's go into the directory that we made, which is the CD test. If I say ls here, you can see it's test. So let's go into it. Oops, CD test. All right, now we're inside. And if I do ls, you're gonna see that we have our Docker file and the application file. All right. Now, what we need to do is just change a line inside that app. So I'm gonna just change welcome to Docker, hello world to welcome to Docker. So to do that, you just need to say nano, and then app.js. Oh, let me increase the size of this thing. App.js. All right, and you can see here, obviously you can only interact with it with the buttons, the arrow buttons, all right? You can't just do this here, right? So let's go to this and change it to welcome to the cloud. To the cloud. All right, and then I'll say Control X, press Y, and then press Enter. All right, now it's saved. If you want to check, you say cat.app.js, and you can see here that it's to the cloud. All right, now we changed that. Let's build it again, but let's make sure that we tag it with version 0.2. All right. This is very important. Otherwise, it's going to take latest as the tag. And then we press enter. So something cool you're going to see here. You see, step 1, what happened is that instead of it actually pulling again the image, it's just used it from cache. And that's the same thing they did. So the cool thing about Docker and containers is that they don't pull again like the resources for the layers that you used to build your images with. They share it as well. So if you already built the first 5 layers and you just change the last one, right? It's just gonna pull it from the cache and then just do the change that it was requested on the last one. Usually what they tell you is that if you have something that changes too frequently, a layer that changes frequently, like for example, your app or service, you put it as the last thing inside of your Docker file or manifest to make sure that you don't have to build all of the layers again just for that one. Okay. Let's go to the next part. Now let's run that one. You can just copy this. So now we're gonna use port 8080 instead of 80. We can't use 4000 because it's already in use. So let's do this. All right, let's say Docker, and you can see here the first image is live and it's on port 4000, and the second one is on port 8080. All right, now let's make a call to that one. Curl, and we got it. The message says, "Welcome to the cloud." Nice. All right. Now, if we call the 4000, it will give you hello world because it has a different image. It was working on the older image. All right. I wonder, any questions? No questions. All right, cool. Let's finish it up. So the last part is debug. Now I want to see the list of what do you call it? To follow the logs output while you're running the container. So you can use the tag -f option. And let's do this here. All right, so Docker logs -f, and I want to put the container ID. For example, this container. Oh no, this one, the one that we just made. And we're gonna do this. Now, to follow the log, remember, you can't do this on this terminal. You have to open a new one. Let's increase the size of this thing. And on here, you can actually do this. So interacting with the bash. So you want to have an interactive bash session where you can do anything, interact with the kernel itself. You can do something called Docker Exec. So as I said, we have to open a new terminal. Let's copy this and change the container ID. The container ID is to the one that we just activated here. Where is it? Yeah, this one. All right. And now we're inside the bash. You can see here inside the app service. All right. So one thing you should also know, that IT flag lets you interact with the container by allocating fpc to TTY, which is like, it keeps your STD in open, so you can type in commands and interact with it. So yeah, where are we? So if you want to see something cool, if we do ls, this gives us, it tells us that we're inside the app. Remember, we set the directory as app in the Docker file, and then we told it that it should include it inside the container. That means it included all of the files that were part of that. directory. So Docker file and app.js become are now inside of it. Yeah. Now let's exit this. Now we're not anymore inside the interactive session. You can examine the containers metadata using Docker inspect. So let's do this. Docker inspect, and let's use the ID that we got. And you can see all of these information. This is the information that describes the container. All right. Obviously, you can use the formatter, and using the formatter, you can go specify something specific inside of it that you want to know. Like, for example, what kind of network or what kind of IP address is this container using. So if we do this, right? We have to put also the ID. Where is our ID? I think it's 07, right? 07, you can just do this, 07, say enter, and it gave you the IP address. All right, so I think you can check out the rest of the resources on Docker. You can find them here as references. Now the last, this is the last thing, which is publishing. So we're gonna push to Google Container Registry. Docker has its own registry, by the way, but we're gonna use the GCR one, and that you'll remove all of the containers, and after that we're gonna remove all of the containers and images to simulate a fresh environment, and then pull and run our container from the registry. Okay, so to make sure that we push the images to our private registry correctly, we use the following. We need to tag the image with the registry name. So the format will be the host name, all right, and then the project ID, image, and the tag. So our host is going to be the GCR, as I said, and then we're going to put the project ID. I'll show you where to get it, and then your image name, and any string tag you want to put. But if you don't put it, it will default to something called latest. Okay, so let's do this first. You can do the step to give you the list of projects. So let's copy this. I'll work on a new terminal so we can see things clearly. All right, so let's do this. Cloud config list project. This is your project ID, all right? And what we're gonna do, we're gonna make sure to tag it with 0.2 because it is version 0.2. So let's copy this and let's edit this part with the project ID. All right, let's press enter. Now what it did, it tagged it. And let's check our Docker images. All right, you can see here that we have this one, which will be from our GCR registry. All right. So the next step, let's push it. So we're gonna push it with the ID that we set up. So let's say Docker push, and then make sure to copy this part. All right. So we have to make sure that it is correct. GCR.io, and then the project ID, not node-app, and then colon 0.2. And then we'll press enter. So what it's going to do is pushing all of the layers that we have. Or that we need for this image. So as it does that, let's continue here. And we'll just say that it pushed all of them. So let's check. The images exist now on the GCR, and we're going to just visit it by typing the link that we already created for it, which is this here. Node app, right? Let's see until it finishes. It's taking a while. All right, that is done. Now let's do this here. Let's say enter, and it should show us. Yay, we got our image. Do you see it? It's here, and it has the tag that we have 0.2. Cool. You want to make sure it is the same 0B17, I think. If you look here, it should have the same digest, which is 0B17. All right, cool. Now the last step, oh yeah, the last part is we have to clean this. And let's copy all of this and remove all of the containers that we have. Yeah. 1 second. Yeah. So Docker stop. So what this do is gonna remove all of the stop all of the images, and it will remove all of them. This one will remove all of them. Now we have all of them removed. Now let's do the next step, which is you have to be careful when you're doing this. We need to remove the child images. So to do that, we need to make sure to replace project ID here, right, with the one that we were using. All right, let's do this. Untagged, deleted, and then we got an error that says no image as node app. To do that, we need to remove the rest of these as well. Okay. Oops, I might have done something. Let's see. We are getting lots of errors. Let's see. Let's list them. Say Docker images. And we don't have anything. Okay, that's fine. It said error because they got deleted on the first step here. Okay. And now we don't have any Docker images. Now the last part is to pull the image that we created from the registry. So let's say Docker pull. And we need this. Yeah, here it is. Where is it? This is it. All right, we're gonna pull it. Right, make sure that it's exactly the same way done, and don't forget to use the correct project ID. Oops. All right, let's pull the image. It's pulling everything now because we've deleted everything that we had, so there's no cache. Okay, then the next step is we're gonna run it. All right. Remember, we're using the option -D to make sure that it's running in the background. Right, everything is here. Let's do this. Let's use our image. Yep. Okay, I created a container. Let's try and make curl com. And it is there. You see it? Welcome to the cloud. And we're actually done. Okay, now make sure to check your progress so you can actually mark that your lab is done. Congratulations, you're done with your first lab, which is Introduction to Docker. We ran containers based on public images from Docker. You built your own container images and you pushed them to the Google Container Registry. You learned ways to debug running containers. You ran containers based on images pulled from the Google Container Registry. All right. Okay, let's see. How is everyone doing? How is everyone doing? That's the first lab, guys. So I want to see if everyone is ready for the next one.
So it's very interesting that we had no questions. So I'm assuming everybody's done this and they're at complete, and we should be very proud of you. If there are any issues, then please write to us, because we can't go to step 2 unless we finish step 1. All right, we're hanging around in the chat.
Let's see. Okay. No questions at all.
One note, if everybody's just watching and not trying, then just a piece of information, this code will not work past 12 o'clock at night. If you do not activate your Quick Lab and start it, then you won't get the month access to the platform. You won't get to be able to finish this lab or anything like that, because it just won't work. Okay.
Okay. I just want to know, at least send yes if you finish the first lab. Hands up, anything? All right. Okay. Dr. Zainab is done. Dr. Arwa is done. Stefan, did you do it? Okay.
Sure.
Let's continue with the next one. Okay. The next lab, let me share my screen again. We are doing this. All right. Cool. Miriam is halfway. All right. Let's go to the next lab. Okay, so you can press the back button here. You can skip this because we already used the code, right? And you can see here the hands-on. Yeah, this one will obviously be marked as completed. Now, the next one is Kubernetes Engine Quick Start. This one is also an easy lab. Just gonna close this. Okay. So a quick overview. Google Kubernetes Engine, or GKE, provides managed environment for deploying, managing, and scaling your containerized applications. So the Kubernetes Engine environment consists of multiple machines, specifically compute engine instances, which we will call them nodes. So they are grouped together to form a container cluster. So in this lab, you get a hands-on practice using it. Let's go. So cluster orchestration with Kubernetes. A quick thing that you need to know is that the Kubernetes engine clusters are powered by Kubernetes. Kubernetes on its own is an open source cluster management system. So you can actually use it on Google Cloud, AWS, I think what other services are out there? Any other services, since it's an open source cluster management system. So Kubernetes provides the mechanism through which you can interact with your container cluster. Again, the cluster consists of something called nodes, worker nodes, and master nodes. So to use Kubernetes commands and resources to deploy and manage your application, perform administration tasks, set policies, monitor the health of your deployed workload. All right. Let's see. Where are we? So what we're gonna do here, when we run the Kubernetes engine, you can actually load balance, use load balancing for compute engine instances. So it will actually handle all of the load balancing on the containers that you have, the instances that you create. It will it includes node pools that are designed designate subsets of nodes within a cluster. So you have something called the cluster, which is a network, and then inside the cluster, the cluster consists of nodes, and inside each node you can have subsets of other nodes within them. And then you have something called automatic scaling for your clusters node instances. So you can actually, if you have one node, again, a node is a container instance that is part of the cluster, all right? And you can use it is that you can create multiple other instances of it that can help you scale your what do you call it, your project. Automatic upgrades for your cluster, node auto repair. So if one node is down, another node will be up. You can actually manage the health of that node. So let's say the service is down or there's something wrong with it. So you can actually do that through the Kubernetes, what do you call it, management platform. You can log and monitor whatever is happening on the cloud cluster. Now, let's set up. Remember, it's the same steps that we always do. So we're gonna press first start lab. All right. Not a robot. And let's chimneys. I think these are chimneys. And we're gonna use it with our credit. Okay, wait. And let's open this in an incognito window. Make sure. Now we're not gonna use the same user account that we used last time. We're gonna use a new account. And let's copy the information they gave us. Next, we copy the password. Next. And then we accept. Do not update anything, just confirm. Oh my. Something went wrong. Let's see. Sometimes these things happen. And then next, password. Next. All right. Okay. Again, we accept, agree, and continue. And we open the terminal. Activate Cloud Show. Say continue. Make this. Let's hide this. Let's wait for it. All right. Then after activating the Cloud Show, let's make sure we are using the correct project. Yep. So 0.0455F6, and it is the correct one. All right. Now what we need to do, setting the default compute zone, just copy this and pass it here and got updated. All right. Now let's start by creating a Kubernetes engine cluster. A cluster consists of at least one cluster master, as I said, which is a node master, we call it as well, and a multiple worker machines, which we call them nodes or worker nodes, all right? Nodes are compute engine virtual machines instances that run on the Kubernetes process, and it's necessary to make them part of the cluster. So there is a basic understanding that you need to make sure that you know is that you cannot run a cluster with less than one, what do you call it, less than 3 nodes, and one of them has to be a master node. Obviously, there is higher scaling that you can go with. So there is something called, this master node is the master node that does decision making for all of your worker nodes. And it can decide if a node needs to be restarted, node needs to be down, shut off, and things like that. It manages everything. So it does the decision management for you. So there's a thing that you have to do when you try to scale your cluster is that make sure that your masters, you either start with 1 and then you go to 3 and then you go up to 7. Because what it's going to do, it's gonna like negotiate with each other, and for you to make sure that it is what do you call it, doing like the decision is happening based on like the possibility of at least 70% of them agree. So it has to be done in like these numbers. I think you can scale your cluster up to 30, I think. I'm not sure if I remember correctly. Yeah. So the next step is to create our cluster. So let's run the following command, which is gcloud container cluster create. So let's give the cluster a name. I'm gonna call it my cluster. All right. And press enter. Make sure to authorize. Don't worry about the warnings. This takes actually a while. So let's see what we can do while this thing goes up. I could actually, yeah. So first thing, what it's doing, it's deploying the cluster. And then next one is it's supposed to set up the master node. Yeah, it's gonna take a while. Let's see if you guys have any questions. No questions so far. Oops. Okay. Let's go back to this. It's actually gonna take a while. Okay. Now it's doing is it's checking the cluster. Okay. We are almost done with creating this cluster. All right, so it got created. So you can see that this is your cluster and where it is located and the master version, master's API, and you can see the node version and how many nodes do you have? You have 3 nodes. One of them is a master node. All right, and it's running. Okay, so you can check your progress here. Cool. It is checked. And then let's get authentication credentials for the cluster. So after creating your cluster, you need to get authentication credentials to interact with the cluster. To authenticate the cluster, we need to run the following command. And we need to use the cluster name that we set up. My cluster. And it is done. Okay, so what it did here, it fetched the cluster endpoint and authentication data. Kubeconfig entity was generated for the cluster. All right, and then we go for deploying an application to the cluster. So you've created your cluster and you can deploy a containerized application like the one that we just made. So for example, we're gonna run Hello App in the cluster. So Hello App is I think it's a node application that we're gonna push to one of the nodes. So when I say node application, it's not the same as the cluster node workers that we're talking about. All right, so Kubernetes Engine uses Kubernetes objects to create and manage your cluster's resources. So what happens with these is that you have something called a deployment object, and for deploying stateless applications like web servers, for example. And then you have something called service objects. And these define rules and load balancing for accessing your application. So each one of these, we create something called a manifest, and we have like the information that we need to describe inside of them to tell what kind of deployment it should have, the information it should have, and the service it should have. All right, so let's run this first command. So this is kubectl is Kubernetes command line tool that we're going to use. And let's create a deployment. All right, just copy that and let's say here. Right, so our deployment was created, if you can see it here. Cool. And now what we need to check the progress. Oh, why? It should say it created it. Interesting. Failed to create deployments. Already exists. What have I done? Oh, okay, now it's working. Okay. Yeah. So the Kubernetes command creates the deployment object and represents the hello server that we just created. And in this case, the -- image here is the one that we're getting from GCR repository. And it pulls it first. And then what it does is that it indicates that the specific image, this is the image that we want to use for the container on the worker, on the node that we're, for the deployment that we're doing. Now we need to create a Kubernetes service, which is a resource that lets you expose the application to external traffic. So for me to actually use the APIs on. So let's do this. So you can see here kubectl expose deployment hello server, and with the load balancer to 8080. So the load balancer type creates a compute engine load balancer for your container. And the port here is to obviously specify which port that we're exposing. Let's do this. All right, cool. It's exposed. Now, the next step is let's inspect this service, right? We'll do it by kubectl get service, and you can see here it's a hello server, load balancer, the cluster IP, and then the external IP is still pending because it's actually what do you call it? Running it. The ports that we're exposing. Let's do this again. kubectl get service, and now we have the external API. We will need this. All right. Now, using that external API, let's open it here in a new tab and say HTTP. And let's see. Ta-da! We got our service. Hello world version 1.00 and the host name hello server with the ID. Awesome. And let's check the progress. All right. And the last thing that we gotta do is just let's clean this up. So we're gonna use the gcloud container cluster, delete, let's delete it. Make sure to use the correct cluster name, Y cluster. Yes, please delete this. It will take a few minutes, I think. And that is the last part of Kubernetes Engine Quick Start. All right, it's gonna take a while. When it's done, you just click check my progress and make sure you end the lab. All right, I think we are done for this one. Let's stop sharing. Okay, so what do you guys think so far? Any comments? Any issues? Any questions? No questions.
I think that was a great session. What are you thinking moving forward? Do you want to go on to the next one, or shall we call it as
I
part?
feel like it might be too long for them.
Okay.
What do you think? How long have
No,
we
let's
been
get
on?
thumbs up.
For 2 hours so far?
In the chat, thumbs up if we continue, or shall we stop?
We have a very silent audience today. Okay. I guess no one is interested in questions. And no one is interested in telling us if they want to continue or not. All right. I guess what we're gonna do is we'll stop here, and we can do a part 2 maybe later on, where we pick up from where we left. So what we have left so far is what I was gonna show you, orchestration on Kubernetes. Maybe I can actually do more explanation and go over the old information as well, to refresh your minds. So yeah. Thank you, Dr. Zainab. Thank you, Arwa, and thank you, Sheikha. I'll leave the mic to Sheikha.
All right. Thank you, Shuruq, for this amazing informative session. And thank you, everyone, for joining. I hope you all had a great learning experience. Since no one is going to ask, I'm not sure. So just wanted to highlight, there will be a recorded version of this session in YouTube. So I'm gonna share it in chat. And also, if you are interested to join our G2G Kuwait community, we as a Google developers group in Kuwait have a Slack channel where we post our upcoming events and informative posts that will add to your knowledge and keep you up to date with G2G Kuwait recent tech events. So yes, I will share the link for the Slack channel. Right. And also, don't forget, we will be happy to receive your feedback for this session through the session feedback email that will be sent to all of you. And thank you. Looking forward to see you all in our upcoming sessions. Have a nice weekend and stay safe.
Before we end this, I think we got one question, apparently. It's from Miriam. She says there's an invalid port problem. So I'm not sure what exactly what were the steps that you went through, but you have to be careful when you're assigning ports. So for example, if you have an already in use port, all right, you might get that issue. So make sure that you don't have other containers using the same port that you're trying to expose. So yeah, I think that should answer it. So yeah. I guess that's it.
So I'm going to keep the room open probably for another 5-10 minutes, just in case they are just going through it and a little bit behind, because some of them were still not completed the first part when we started with the second. So just as support, we'll be here for a short while. Otherwise, I wish you all an amazing evening. Thanks, Shuruq, for the workshop. I'm excited to see the next one.
So tomorrow we have two actually sessions. The first one is by Michael. He is a Googler. He's gonna give a talk about progressive web apps. And the second one is gonna be by Bob. He is a Google developer expert. It's gonna be using something called Waviate with the GCP, Google Cloud Platform. Make sure to go on our main page for the chapter. You're going to find all of the upcoming events there, and make sure to sign up for them so you can benefit from the sessions. All right. Thank you guys for coming. And it was nice having you all.